This week I just wanted to make a short video that would talk about how the approach that we took in this course connects to the other introductory statistics courses that you may have seen or might have taken otherwise. Our book used a statistical modeling approach to introduce key statistical concepts. Many of these are the same concepts you'd see in any introductory statistics course. For instance, we looked at how to summarize variables with descriptive statistics and graphs. We talked about how to use sample data to draw inferences about a larger population and what would constitute a good representative sample. We talked about how to calculate and interpret confidence intervals. We used sample data to test hypotheses about what might be true in the larger population. And we examined relationships between two variables, an explanatory variable and a response variable. Some of the things that I think we gained by using the modeling approach were the ability to examine systems in which we need to consider multiple explanatory variables and/or covariates that might be acting as confounding variables. In a traditional course, you really only get to look at an introductory level at relationships between two variables at a time. This approach allowed us to have the ability to look at relationships that were more complex. We also gained some exposure to some non-parametric simulation-based methods that we don't normally cover in introductory courses. For instance, bootstrap confidence intervals based on the resampling distribution and the permutation tests that we saw. For students who've already taken other statistics courses, hopefully it helped you see connections between some of the things that you've seen only separately in other courses. For example, using the grand mean model and how that relates to the descriptive statistics for a single variable, using categorical explanatory variable to compare the means between two groups, and those kinds of things. And some other useful tools that don't usually come up in an intro course were indicator variables and this connecting analysis of variance and regression. Often they're seen as separate topics in an introductory course, but without making a connection between them. So those are some things that I hope we gained. Some things that we didn't see, though, because of the approach that we took and because of, the move to remote learning partway through the semester. We did not get a chance to work with categorical response variables. We would have done that if we had been able to get to chapter 16, but I just felt like I was going to have to push too hard given the remote learning setting to do that. So if that's something that you are working with in your research or something like that, you may want to go ahead and work through the material in chapter 16 that focuses on logistic regression, which works when we've got a categorical response variable with two possible categories. We also missed seeing some of the traditional ways of conducting hypothesis tests, like a t-test for a difference in means and a z-test for proportions and chi-square tests. We did not cover those things in this course. Some of them we would have talked about a bit, like the chi-square tests, if we had made it to chapter 16, but some of them we didn't talk about explicitly at all. And so part of what I want to do is show some of the connections between the way that we did things in our course and how we would normally see them in a traditional course. So for example, if we are thinking about testing for a difference in means between two groups, and we'd been doing this when we have a quantitative response variable and an explanatory variable that's categorical with two categories, in a traditional course, you would see this as a t-test for a difference in means. Using a modeling approach, we fit a model that looks at the response as a linear function of the explanatory variable. And then we do either a NOVA F-test on the whole model or a t-test on the coefficient for the explanatory variable. And either of those are actually going to be exactly equivalent to doing a t-test for a difference in means using an equal variance assumption. Generally speaking, the results you'll get using an equal variance assumption are very similar to what you'd get if you use the unequal variance assumption, which we typically see in a lot of the intro courses that we teach. But and in the situations where they are very different, it makes sense to do a non-parametric test for the most part anyway. And so in that situation, doing those permutation type tests would be another better option for you. If we're working in a situation where we have paired data, generally what we are going to be interested in testing is to see if the mean difference is different from 0, which would indicate that there's a difference within each pair in the response variable. In this situation, the response variable would be quantitative. The explanatory variable would be categorical with 2 categories. And we'd additionally have another variable that would just be identifying which pair each observation was part of. Now, in a traditional course, we'd use a paired t-test to test to see if the mean difference differs from 0. Using the modeling approach, we can test to see if the response, we can use a model that fits the response variable as a linear function of the explanatory variable plus the variable that indicates which pair the observation is part of. And when we do an ANOVA F-test on the whole model, that will be equivalent to doing this paired t-test. If we want to test for a difference in means between more than 2 groups, in a traditional course, we do an ANOVA F-test for the difference in means. And in the modeling approach, really we do the same thing. We fit the linear model for the response variable as a function of that explanatory variable, which would be a categorical variable with 3 or more categories. And then when we did the ANOVA F-test on the whole model, that would be equivalent to doing our test. And finally, if we were testing for a difference in proportions between 2 groups, so here we'd have explanatory and response variables that are both categorical with 2 categories each. In a traditional course, we'd do a z-test for a difference in proportions, or potentially a chi-square test for association between the variables. Using a modeling approach, we can actually fit the response variable as a linear function of the explanatory variable, where here, again, the response variable is going to be categorical, and the explanatory variable is also going to be categorical. And when we do the ANOVA F-test on that model, it's not exactly equivalent, but it's going to give you a result that's going to be very, very similar to the p-value you get from this z-test or chi-square test. So just to talk a little bit about how those traditional tests relate to the modeling approach. And there's more discussion of this in the additional resources, part B, in the back of the textbook. If you're still thinking about any statistics courses for the fall, a couple of good options would be STAT211, which is called Statistical Methods 2. It's intended to be a follow-up to this course. It does a lot of work with ANOVA and regression, but in more depth and with a bit more mathematical rigor. It also will take things farther than we were able to go this semester. And then STAT235 is categorical data analysis. So that would be focusing on the situation where your response variable is categorical. So if that's an area of research, if you're working in an area of research where you tend to have categorical response variables, then STAT235 might be a really great course for you for the fall. Last thing I want to do really is just thank you for being in class this semester and for your patience as we have tried out a new textbook that has a very different teaching approach and had to switch to remote learning, which was not what any of us were planning for. I took this approach because the audience for STAT211 is so sort of dichotomous. There are a lot of you who are undergraduates who've taken other statistics courses, some of you several other statistics courses, and have already seen the traditional confidence intervals and hypothesis testing using normal and t-distributions. And then there are also lots of students in class who are graduate students who some of you haven't taken any formal statistics courses before, and you might not have time to take any more while you're here at UVM. So I think even for graduate students and undergraduate students, if you're doing any research, you're working with systems that require the study of more than just two variables. So I really hope that this course gave you something new, either a foundation to build on if you're newer to statistics and you're working in research, but also that if you have seen some of these things before, that this course helped you to develop deeper understanding of the concepts that you've seen. So again, that's my hope, and I appreciate you bearing with me through some of the sort of trial and error that came with some of the new things that we had to implement. So just about reached the end, but for Thursday, remember there is homework 11, which is to finish up those last questions from the handout we were working on in the live meeting on Thursday. So that should be done for Thursday. It's due Thursday night. I will answer questions about it during office hours on Thursday. Office hours in place of the regular class, so feel free to stop in with your questions. If there are topics you specifically want me to review, feel free to send me an email. I'm happy to either schedule a live review session to cover them or to make videos covering those topics. So if there's something that you would like me to make review for, please let me know. And then just some information about the final exam. The final exam is going to be untimed. It's going to be take home. It will be available Thursday, April 30th, and it will be due on Tuesday, May 5th. The length of it will be fairly similar to the midterm exam, just to give you a sense for how much time you need to budget to work on it. And it will be cumulative, but with a heavier focus on the material after the midterm. Thanks, and have a good day.